Hello, students. So this is how you're going to check for your mistakes in the checkup quiz. So in the description, I'm going to have timestamps for the different problems. So if you didn't miss number one or you don't want to watch number one, click the timestamps to go to the different problems that you want to watch. This is going to be one long video broken up into different timestamps. So here is question one. Here's a survey. We are told that Ricardo, the soccer league director, made the following statements. For each statement, tell if it is accurate and explain how you made the decision. Here, we need to recognize that Ricardo said during the game. They put it bold. They put it in bold. So we know we're talking about these data points, all right? The players prefer juice to water. Now, here, when they say juice to water, we need to recognize that they are giving us a comparison part-to-part ratio. And here's the important part. When they give us a ratio, the order in which the ratio is said is important. So here, when the ratio is given to us as juice to water, then we need to recognize that the data should also reflect that same order, that we should see a ratio of juice to water. And what we find out is when we create a table, and in that table, this is going to need to be a little bit bigger. I can fit. So, and we have juice and water. We bring juice in from our data table. It is a number of, what is it, players? Yes. 10 is the number of players that prefer juice during the game. Water. 40 is the number of players that prefer water during the game. We go ahead and reduce this ratio by dividing by 10, and we get a ratio of juice to water, which is 1 to 4. Then we look at our statement, and that is not what Ricardo is saying. Ricardo is saying that the ratio is 4 to 1. Here's our evidence that the ratio really should be 1 to 4. So our explanation is that Ricardo is not correct. So we would write this out. So you would need a written explanation that Ricardo is not correct because he got the order wrong in describing his ratio. This would be your evidence right here that that would be your evidence and proof that you calculated the correct ratio, and showing that, this should be, 1 to 4 instead of 4 to 1 in that table is fine. Your explanation would be that he got the order wrong. Those two pieces were in good shape. So that is telling if it is accurate. No, Ricardo is not accurate. Explaining how you know. We're going to explain in both words and some sort of calculation. Sound good? Okay, so that's the end of number one. And we needed to see all of these parts in order to get that correct. Let's take a look at problem 1B. Sorry, that was 1A. So Ricardo made another statement. He said that 25% of the players prefer water after the game. So we need to identify that we're looking at this data. He also said that 25% of the players. So we need to calculate all players, and we need to see if 25% of them prefer water after the game. We're also looking at water here. All right. So what we need to do is we need to figure out total players. So we are going to add, we need to show this calculation, 10 plus 80 plus 30. Adding it up, we get 120. And we need to show that this is total players. Okay. We also know that our percents, 25%, should equal the part divided by the whole. All right. We know that this is our total players here. We identify the players that drink water after the game. So water after the game is 30. So 30 players prefer water after the game. Sorry, I'm running out of, let's just say prefer water. Okay, and then 25% is part to whole. So that should give me 30 over 120. We can reduce this by 30. That gives us a fraction of 1/4. 1/4 equals 0.25. 0.25 equals 20%. Sorry, not 20%. 25%. Therefore, this is enough work to say, we can squeeze that in here, Ricardo was accurate. Sorry for the handwriting. It's not great in the first place, and now I'm bending down. So we would box in our answer here. Check off that 25 equals 25. We've got our part, we've got our whole, we've got our part, we have our whole. We have enough evidence to prove that Ricardo is 100% correct for this problem. All right, so that's what we were looking for part B. We needed to identify what was our total amount, what was our part amount value, and that 25 is a comparison of part to whole, 25%. Math it out all the way down to the end. We get a decimal value that converts to a percentage, and absolutely Ricardo was correct. So that was 1B. Let's take a look at 1C. 1C, this says more than half of the players prefer a sports drink during the game. Now we're back to this data. Again, we need to find totals. So we're going to do 70, plus 10, plus 40. We get to a total of 120 total students, or players, players. You might write, there's a couple different ways to solve this one. 60 is half of all players. 70 students, not students. Sorry, I keep saying students, I don't mean students. 70 players prefer, what was it, sports drink during the game. So 70 players prefer sports drink during. And then 70 is greater than 60. Or you can write it out in a sentence. 70 players is more than 60, which is half of all players. That's one way to do it. Another way to do it was to calculate the percentage. So if you calculated the percentage by showing 70 divided by 120, I'm going to go ahead and write that up here. This is not where you'd write it on the test, but I'm going to go ahead and write it up here. If you showed 70 as, and then writing out players that like sports drink, over 120 total players, and you found out that was, I believe it's 58%, somewhere in the ballpark there, approximately 58%. And then you could show that 58% is bigger. You don't have to show, just write it out. 58% is larger than 50%. Then you have shown enough math. The last thing you need to do is explicitly state Ricardo's statement is accurate. That's it. And your math is the evidence that Ricardo's statement is accurate. But I need to see labeled data, right? What does 60 represent? Where does 70 come from? What does this mean? Adding these numbers together, it's to give us a total number of players. So students, I need you to start labeling your calculations in a way that makes it very apparent where your numbers are coming from. Some of you may have lost points on that. Some of you may have not. So then we're going to go ahead and move on to, I think it is question 2. Yes. Question 2, this is on the back page. Ryan took 15 minutes to type his 450-word report. At this rate, so here we know that we're going to have a proportion. This is going to be consistent. How many words could he type in 20 minutes? Show how you arrived at your answer. Again, multiple ways that this could have been answered. Here's one of them. Creating a data table, which I encourage students regularly to do. We've got a data table here where we calculate, let's see, what are we comparing? Minutes and how many words? So we're comparing minutes and words. So let's go ahead and do words first. And let's go ahead and have minutes here. All right. So at the rate of 450 words in 15 minutes, we write 450, 15 minutes. Now from here, your student could have made many different choices. You could have said, I'm going to try to figure out how to go directly to 20 minutes. And in order to figure out how to multiply, what factor I multiply by to get directly to 20, I would have to take 20 and divide it by 15. That's going to give me an odd number. It's going to go in once, 5 left over, 50. Then it's going to be 3. 3 times 15 is 45, 5, and then this just repeats. So our factor is going to be 1.333 repeating, or 1 1/3. So we're going to have to multiply it by 1 1/3. Well, that's not a fantastic factor. So what I saw many students do was to try to figure out how many words in a single minute that Ryan could type. So instead of trying to go directly to 20, they should divide by 15 and show the work somewhere. They don't have to show it the way I'm showing it, but they need to show that they took this original rate somewhere along the way and divided it by 15 to find how many words that Ryan could type in 1 minute. All right. So now that we know how many words he can type in 1 minute, we simply multiply now by 20. And again, I'm using the table to keep things organized. Your student needs to use something to keep it organized. This is my recommended method for now. All right. So we're going to multiply by 20. So now we got 20 minutes. 30 times 20 is going to be 600. I don't actually need to see the students write out 30 times 20 and drop a 0 and a 0 and a 6. I don't need to see this part. I can assume they do that in a calculator, but I do need to see the fact that they organized that problem. I need to see that they started at point A, took an action, and ended up at point B, and that those values, those numbers have specific unit values associated with them. That the 600 isn't just some random number, that this 600 is associated with 20, and this 600 represents number of words, and 20 represents number of minutes. All right. So then here, then the statement would be to explicitly say that Ryan can type 600 words in 20 minutes. Okay. Now, if your student showed these calculations in multiple places, I just need to see some sort of labeling as to how they did that. This is why I encourage students to organize things in a table, because each cell is labeled already with the heading of that column. We're going to use tables a lot in graphing. I am trying to prepare them for graphing, which is coming up next. So I hope that they went this route. So for part B, I don't think I took much off if students got these wrong. It might have been a point or two, because the correct answer is this, and the correct answer is this. And we haven't talked about proportional association yet. And what I mean is that the reason this is correct is because we're comparing minutes here in the denominator to words, and this pair represents a data point in our rate table up here, because for 450 words, it would take Ryan 15 minutes to type. And as we move over to the other side of the proportion, minutes are also in the denominator here. Therefore, words in 20 minutes would be in the numerator. All right. The reason this one is not correct is because 15 minutes There's no problem with having minutes over minutes. That's fine. But here, minutes in the numerator needed to match the number of words for those minutes in the numerator on the other side of the proportion. And because 450 is in the denominator instead of the numerator, this is not correct. Again, we have the same issue. No problem with having minutes over minutes and then words over words. That's fine. But here, 20 does not correlate or pair up with 450. All right. 15 minutes does. So they need to be in the same position in the proportion. This is not correct. Here, again, we have basically the same as the first one. Here's 15 minutes over 450 words. And then we also have minutes in the numerator. Either of the proportions at the beginning or the end could be solved to find the correct answer of 600. That is 2A and 2B. Finally, here on part 3, students were told that what they primarily needed to show was not only the answer, they have to tell me what x equals. It does say find the value of x. They have to show me what x equals. But I wanted them to also show me some way the factor that they used to find the missing value. So here, I would expect students maybe hopefully even to rewrite this. 3 times 8. So I know that they're increasing this as by a factor of 8 because it's 3 times 8 that will give them 24. Therefore, 4 times 8 is going to give us, oh my goodness, it's late. 4 times 8, 32. 32. So then they need to show, this is what they multiplied by, and x equals 32. Now, we didn't do this a lot in class. We did it enough, and there was enough support during the quiz that I would expect something close to this kind of answer. But I tried to be liberal with as many points as I could give for students who gave this their best go. Because this one's fairly straightforward. B is also straightforward. 2 over 3 equals, we realize that we have to multiply 3 times 5 to get to 15. Therefore, up here, the answer is 10. X equals 10. I need an explicit answer. We're really looking for an explicit answer. And here is our factor that we used. Now, here, a lot of students mess this one up because they weren't looking for that factor. And we weren't realizing now with the X on the left-hand side that direction here matters. So many of them saw that I'm going to multiply this times 5, but that's directional. A lot of students then multiply this times 5, but that's in the opposite direction. And if we're going to go the opposite direction, we have to use the opposite operation, which means we should be dividing by 5 if we're going the opposite direction. Because if we change direction here and we went from 25 to 5, that would be really obvious that we need to divide by 5. So here we would need to divide by 5 to figure out what x is. If you haven't figured it out yet, x is equal to 1. So what I'm hoping students, and I didn't see any students do this, is that if we're going to find a factor here, it's going to be to figure out that we multiply by 5. That's fine. But then we have to figure out that we are multiplying by 5 here. So what number would I multiply by 5 to get 5? Well, this would have to be 1. It would have to be 1. So what I need students to show here is some sort of work where they're logically working this out, and then let me know that x equals 1. All right? Most students that got this right, instead of going from left to right, they said, oh, wait a minute, I got it. I divide by 5, and that'll get me my answer. All right? So finally, we end up in that same kind of situation here, except for we have a couple options. We could have noticed, and this is another way to solve proportions, we could have noticed that the denominator is actually, oops, arrow's the wrong way. denominator is 3 times the size of the numerator. And that would have given us the fact that x equals 12, all right? But if we couldn't find that out, then we would have to find out the factor that we multiply 4 by to get to 10. And that's not obvious, right? It's not 2, it's not 3, it's somewhere in between. So students hopefully took 10 divided by 4, because the opposite of multiplication is division. 4 goes into 10, 2 times 4 is 8, 2, 0, 0 goes in 5 times, and they realize the factor is 2.5, all right? So if I multiply by 2.5, I will get my answer of 10. Problem is, again, since we're going the opposite direction, we need to divide by 2.5. So we would have to take 30 divided by 2.5. All right, move the decimal, and 25 goes into 300. 25 goes into 30. Sorry about that. 1, 25, 5 left over, 50 goes in twice, 50, 0 remainder. Our answer is 12. X equals 12. All right, because we needed to divide by 2.5 to go the opposite direction. So that's the entirety of the test. It's pretty hard giving partial credit and trying to give as much credit as I can for students who are showing their work. But these are the answers and the work that we're looking for. X equals 32, X equals 1, X equals 10, and X equals 12. And we should see enough work to support those answers. All right. So thank you very much for taking the time to watch the video and correct your work. Some or many or all of these problems will be on the final unit test. Again, thanks for watching, guys.